158.1, enter. Yeah, we can get replay. Now here I will just given trace route. So trace route means the PC1 can communicate to ISP through R1 router, that is 172.30.200.1. so through this R1 router we can communicate. So in R1 router is an active virtual gateway, so it's only responsible for ARP request. So now the PC1 can request the ARP request for default gateway. So the R1 router have virtual MAC address for R1 router and R2 router. So the PC1 requests the ARP request means it will respond to the ARP request and sending its own virtual MAC address, that is 0007B401.F401. and now PC2 can request the ARP request. So that time R1 router responds to the ARP request of PC2 and send its R2 virtual MAC address, that is 0007.B401.F402. so now PC1 and PC2 can communicate to ISP. So the PC1 can communicate to ISP through R1 router and PC2 can communicate to ISP through R2 router. So here the load equally balance the load. By default in GLBP your configure means the default load balancing is round robin. Okay, we can check. So now PC1 can ping to ISP. Just we have to trace route 117.203.158.1. Here we can see 172.30.200.1. so now just check the ARP, show ARP. Yeah, here we can see. So just we have to clear this screen and I will show it to you. Show ARP. Yeah, we can see. So the ARP address is, so the MAC address is 007.B401F401. It's an own virtual MAC address for R1. Now go to the PC2 and ping to the ISP. Ping 117.203.158.1. so we can get replay. Just we have to trace route 117.203.158.1. yeah, here we can see 172.30.200.2, that is an R2 physical interface. So PC2 can communicate to ISP through R2 router because R1 router, the PC2 can request the ARP request for the default gateway. So R1 router can respond to the ARP request and it send its R2 virtual MAC address. So that's why only PC2 can communicate to ISP through R2 router. Yes, we can check the ARP, show ARP. Yeah, here we can see the virtual MAC address is 007.B401.F402. in PC1 F401 is an virtual MAC address for R1 router and PC2 the virtual MAC address of R2 router. So again we can go to the R3 router and ping to ISP. So that time R1 router can send its own virtual MAC address. If you have another PC4 means that time PC4 can ping to ISP means, so that time R1 router send its R2 virtual MAC address. So it will equally load balancing. So just ping 117.203.158.1. we can get ping. Now trace route 117.203.158.1. here we can see PC3 can communicate to ISP through R1 router. So check show ARP. Here we can see 007B401F401. So by default load balancing method is round robin. There is three load balancing methods are there. Round robin is by default and waiting, and another one is an host dependent. We can check. So go to the particular interface 0/0 and GLBP and group number is 500 and here load balancing. So load balancing, here we can see host dependent, round robin, weighted. So host dependent means PC1 only the particular virtual MAC address can communicate to the ISP. For an example, I will configure host dependent means the PC1 can learn this R1 virtual MAC address, means every time the PC1 can communicate only through R1 router only. So if you configure host dependent means all the PCs can communicate to ISP through only one virtual MAC address. So this active virtual router cannot forward the traffic if you are configuring host dependent means. Okay, next one, round robin is by default it load balance equally. Next, weighted means just we have to given the weighting value in R1 router and R2 router. By default is 100 and 100, so that means equally load balancing. For an example, in R1 router I will give the weighted as 50 and R2 router I will give the weighted as 100. That means here 3 PCs are there. So if the weighted value is 50 and weighted value is 100 for R2 router, means R2 router at a time 2 PC can communicate to ISP through R2 router and only 1 PC can communicate to ISP through R1 router is 50 and 100. That is